What is an elementary reaction?
Reaction in which rate equation corresponds to stoichiometric equation and rate equation.
Excellent, excellent. So now you know what is elementary reaction, what is order of reaction. Now we'll see, compare these and see how they are different or comparable. Okay, so now we'll do two comparisons. One is between elementary and non-elementary reactions. Okay, so if you can see this, it's a comparison of elementary and non-elementary reactions. So first comparison says elementary reaction is a single step reaction. There is only one step. That's why it's called elementary reaction. And non-elementary reaction is multiple step reaction. It may be involving some other steps, which we'll see later. How are they involved? But it is not a single step, it is multiple steps involved in a single reaction. What we see as a reaction is actually overall reaction, but actually there may be more than one step involved in it. Okay, that's why elementary reaction is simple reaction and non-elementary reaction is complex. Okay. Then third comparison is order of reaction in elementary reaction is equal to sum of stoichiometric coefficient. हमने देखा था, right? अभी for elementary reactions you can add the stoichiometric coefficients of the reaction and that will give us order of reaction. But for non-elementary reaction, order of reaction is not equal to sum of stoichiometric coefficient. What is stoichiometric coefficient? याद है आपको? What is stoichiometric coefficient? किसी को याद नहीं है? So if you look at this example, what is stoichiometric coefficient?
Sir, ratio of reactants to products.
No, it's not the ratio of reactant, but it is basically the number. Yeah. Stoichiometric coefficient is 2 for A and 1 for R. So when you write a reaction, the coefficient or the number of molecules which are reacting of each compound is stoichiometric coefficient. PC में पढ़ा था आप लोगों को मैंने. Right? So in this case, 2 is the stoichiometric coefficient for A and 1 is the stoichiometric coefficient for R. Right? So when you look at this one, order of reaction is nothing but sum of stoichiometric coefficient of reactants actually. यहाँ पर आना चाहिए. Because products are not involved in the reaction rate equation, right? Order of reaction is in the rate equation. So यहाँ पर सिर्फ 2 आएगा stoichiometric coefficient और order for element reaction यहाँ पर 2 नहीं आएगा, right? That's why we can write in this case minus RA equal to KCA square, where 2 is the order of reaction, and in this case where it is non-elementary reaction we cannot write, we will write later this is alpha will not be equal to 2. समझ में आया difference between elementary and non-elementary reaction in terms of order? So in this elementary reaction you can look at the rate equation, reactant का जितना भी coefficient रहेगा that is the order of reaction, whereas for non-elementary reaction it is not the same. ये 2 नहीं आएगा यहाँ पर, ठीक है? Then another comparison is for elementary reaction order is always integer, whereas for non-elementary reaction, it can be integer, it can be zero, it can be a fraction. And integer का क्या रहता है? What are integer values? When you say integer, what does it mean?
Perfect number.
No, give me examples of integer. कैसे कहाँ से start होता है integers?
Sir, 1 से.
1 से चालू होता है. It doesn't start with 0. It is 1, 2, 3, etc. That's why यहाँ पर 0 ऐड किया है. For non-elementary reaction, it can be integer. That means 1, 2, 3. It can be 0 and it can also be a fraction. 0.5, 0.25, 0.75 कुछ भी हो सकता है because it is an experimental quantity. ठीक है? Any questions on this comparison? And this is example I have given. Acetic acid plus ethanol gives ethyl acetate plus water. यहाँ पर order of reaction क्या हो जाएगा? If this is considered as elementary reaction, what will be order here?
2.
1 plus 1. यहाँ पर 1 है. यहाँ पर भी 1 है तो 2. यहाँ पर we cannot say because यहाँ पर भी 1 है, यहाँ पर भी 1. That doesn't mean 2 हो जाएगा. यहाँ पर not equal to 2. Right? And we can write rate equation for elementary reaction as minus R of acetic acid is equal to KCH3COH इसके लिए and concentration of CH3COH and concentration of ethanol. Similarly, rate equation for minus R C2H5OH will be same thing as same thing. So we can directly write the rate equation by looking at the rate stoichiometry for elementary reaction, but for non-elementary reaction we cannot write rate equation in this simple manner. Any questions on comparison of elementary and non-elementary reactions? एग्जाम में बहुत बार आता है कंपैरिजन, सो यू शुड बी एबल टू राइट दिस टेबल. ठीक है? If there are no questions, then we proceed further and then compare molecularity and order. Right? So we have seen molecularity is total number of molecules of reactants involved in reaction, and order is sum of powers of molar concentrations of reacting species in rate equation. अभी देखा हमने, right? जो रिएक्टेंट रहता है उसका ही concentration का पावर जो रहता है वो ऐड करते हैं, that we get rate equation. That is the order. Right? And molecularity is always integer. अभी देखा हमने. Because molecularity is for elementary reactions. It's not equal to 0, not equal to fraction. Whereas order can be 0, it can be integer. Or it can be fraction. ठीक है? And third comparison is it's a theoretical concept to satisfy experimental findings. Experiment से जो order मिलता है उसको satisfy करने के लिए हम theory propose करते हैं, so that we can get the same rate equation. And this is an experimental quantity order. And molecularity is only for elementary reactions, and this is for all reactions. That is overall reaction. It may be elementary, it may be non-elementary. Any questions or doubts on comparison of molecularity and order? ये भी बहुत बार एग्जाम में आता है, so you should be able to write this comparison. Any questions? ठीक है, there are no questions, and we'll proceed to the next topic. which is now for non-elementary reactions. How do we get the mechanism? आप लोगों ने मैकेनिज्म पढ़ा है ना केमिस्ट्री में? याद है किसी को मैकेनिज्म इन केमिस्ट्री? दीक्षिता? Can you hear me?
सर याद नहीं।
यार कैसे भूल जाते रहे? आपको याद नहीं तो बाकी लोग क्या बोलेंगे? ठीक है. So let's see what is mechanism. Okay. We have seen just now that elementary reactions are represented by rate equations showing both molecularity and rate constant, right? अभी देखा था, if you write a rate equation like this, or a reaction like this, 2A gives 2R, this is the reaction. You can write minus RA is equal to R of R is equal to K1 is the rate constant into CA square, where 2 comes from here, right? And we are saying this is an elementary reaction. Then you can write this rate equation, right? So this represents a bimolecular reaction with second order rate constant K1. This is the second order rate constant K1. Order is 2. Bimolecular, that means two molecules are reacting to give product. Okay? Any questions on this one? Now somebody will say, okay, if you are writing 2A gives 2R, why can't we write A gives R? Can we do that? Can you just say कि ये 2 निकाल दो इधर से और इसको A gives R बना रिएक्शन लिख दो? Will it be okay to write A gives R? It will be wrong because then we cannot write rate equation. Because if we write this as elementary reaction, overall reaction we can write this, but it will not be elementary reaction. If we write this, then the rate equation becomes this, because the coefficient here is 1, stoichiometric coefficient here is 1 here. So here we get 1, which is not right. So what we get is rate equation here is correct. What we get here is wrong. Okay? Any questions on why we should not write? You can
Sir,
write.
nice.
Yeah.
Sir, not clear.
Not clear.
QS.
Okay. Suppose we find that when we do the reaction, this reaction, we get this rate equation. This is experimental quantity, right? Rate equation is always experimental. We find this. So we can write a rate reaction which gives 2 molecules of A give 2 molecules of R. That means 2 molecules of A react to give 2 molecules of R, and that is why the order of reaction is 2. And this is an elementary reaction. Then only we can write this as a rate equation. बराबर है?
Yes, sir.
right? Now because this 2 and 2 दोनों साइड में है तो somebody will say कि क्यों नहीं हम divide करते 2 से and right a gives r, right? बराबर. So if you write this as an elementary reaction, if you write overall reaction, then it's fine. If you write this as elementary reaction, then it is wrong because you'll get rate of reaction which is wrong. It will not match with experiments.
Yes.
ठीक है, समझ में आया?
Yes, sir.
Right? So that is why we cannot write it like this as an elementary reaction. You can write it as an overall reaction, doesn't matter. But moment you say it's an elementary reaction, then rate equation becomes different. Okay, so that is why distinguish between reaction which represents elementary reaction and many possible representation of stoichiometry, right? ये which होना चाहिए. So we should distinguish between reaction which represents elementary reaction and many possible representations. ये there is different representation, right? Stoichiometry हम 2a gives 2r भी लिख सकते हैं and a gives r भी लिख सकते हैं, but this is not elementary reaction. This is an overall reaction. If you write as overall reaction, that's fine. But if you write as elementary reaction, then we will give a different rate equation. That's why we should distinguish between these. ठीक है, समझ में आया?
Yes.
Okay. So now, once we know the difference between elementary and non-elementary, now we need to see how we write or how do we write non-elementary reactions, because not all reactions are elementary. Some of them are, so it's easy. But when we encounter non-elementary reactions, then we need to find a way of writing those things, reactions, right? So non-elementary reaction is something in which stoichiometry does not match with kinetics or rate equation. बराबर, ये हमने देखा, right? That is for non-elementary reactions, rate or reaction order and stoichiometric coefficient are not identical, right? Stoichiometric coefficient हमने देखा, उसको ऐड किया तो ऑर्डर मिलना चाहिए for elementary reaction, but for non-elementary reaction that does not match. So for example, if you look at this reaction, hydrogen plus bromine gives HBr. This is a reaction or stoichiometry. So 1 mole of hydrogen reacts with 1 mole of bromine to give 2 moles of HBr. But if you look at experimental rate equation, it's very complex. It is not second order reaction, right? From stoichiometry, if you take this as elementary, second order reaction लिख सकते हैं हम, right? Or if you take this as elementary, then you should get R of HBr is equal to K1 ऐसा आना चाहिए, बराबर ना? करेक्ट है कि नहीं है? If it was elementary. If समझ में आया ये कैसे आया? How did I write this? RHBr is equal to K1HB hydrogen into K2Br2 minus K2HBr square. कितने लोग को नहीं समझ में आया ये? See, this is an important topic and you are going to get questions in exams. In SEM board or final exam, always there is at least one question on mechanism. If you don't understand this, ask now. It's not an easy topic. It's a difficult topic. So if you have any doubts, ask now. And you can ask me as often as you want. रेट इक्वेशन कैसे लिखते हैं हम? हाउ डू वी राइट रेट इक्वेशन? यहाँ पर बिकॉज इट इज अ रिवर्सिबल रिएक्शन, राइट, forward rate is equal to this rate constant into concentration of reactant, और एलिमेंट्री रहेगा तो पावर ऑफ हाइड्रोजन 1 रहेगा, पावर ऑफ ब्रोमीन 1 रहेगा, एंड माइनस रिवर्सिबल है, ये रिवर्सिबल रिएक्शन है, तो माइनस K2 इंटू कॉन्सेंट्रेशन ऑफ रिवर्सिबल रिएक्शन में HBr रिएक्टेंट है इंटू कॉन्सेंट्रेशन ऑफ HBr, और यहाँ पर तो ऑर्डर रहेगा 2, सो HBr स्क्वायर इफ इट वॉज एलिमेंट्री रिएक्शन।
सर हाइड्रोजन का लिखेंगे तो क्या आएगा?
हाइड्रोजन का लिखने का क्या? हाइड्रोजन का लिखने का सेम
सर
आएगा,
रेट
सेम
इक्वेशन।
आएगा, इट्स गोइंग टू बी सेम। रेट इक्वेशन इज सेम, ओनली थिंग इज मैंने बोला आपको, ओनली रेट कांस्टेंट चेंजेस, राइट। ये HBr लिया हमने, एलिमेंट्री रिएक्शन की बात कर रहे तुम, राइट वैभव?
Yes, sir.
एलिमेंट्री रिएक्शन, नॉन
Yes,
एलिमेंट्री रिएक्शन लिया तो ऐसा आएगा, दिस इज व्हाट एक्सपेरिमेंटल डेटा शोस। आई वाज जस्ट अज्यूमिंग कि अगर आपने एलिमेंट्री रिएक्शन लिया रहता तो क्या होता। क्वेश्चन क्या था आपका?
सर जो एलिमेंट्री रिएक्शन के लिए HBr का लिखा ना K1H2Br2, तो वैसे H2 का सेम ही आएगा क्या या कुछ और आएगा?
नहीं, सेम नहीं आएगा। वी हैव सीन दैट रिलेशन बिटवीन रेट इक्वेशंस, राइट, एलिमेंट्री रिएक्शन के लिए क्या था रेट इक्वेशंस का कोरिलेशन? सॉरी, HBr का नहीं होगा, ये हाइड्रोजन का होगा, HBr का डिफरेंट आएगा। ओके, यू राइट। HBr का अगर व्हाट इज द इक्वेशन रिलेशन? माइनस R ऑफ हाइड्रोजन इक्वल टू माइनस R ऑफ ब्रोमीन इज इक्वल टू R ऑफ HBr डिवाइड बाय 2,
हाँ सर,
राइट।
अभी क्लियर सर।
Right. So this is the relation between the various rate equations, rates depending on reactant and product बोला तो rate of hydrogen is equal to rate of bromine रहेगा, और rate of HBr divided by 2 आएगा, and rate of hydrogen is this, ठीक है?
Yes sir.
Is it clear? So let's not go there, it will confuse you, so I'm not going to keep this. Just look at this one. We are going to see कि यहाँ पर जो है एक्चुअली जो रेट इक्वेशन मिलता है एक्सपेरिमेंट से इज वेरी कॉम्प्लेक्स, इट इज नॉट स्ट्रेट फॉरवर्ड, सो दिस इज नॉट एन एलिमेंट्री रिएक्शन, इट्स नॉन एलिमेंट्री रिएक्शन। So how do we derive this equation? We have to see, एक्सपेरिमेंट से हमें डेटा मिल जाता है, रेट इक्वेशन मिल जाता है, देन वी नीड टू हैव सम theoretical basis for that also, and that is what we do in finding mechanism. Purpose of mechanism is to find the rate equation theoretically which will match with experimental rate equation. ठीक है? So mismatch between reaction order and stoichiometry indicates that we must try to develop a multi-step reaction model or mechanism to explain the kinetics, to explain the rate equation. Kinetics is rate equation. ठीक है? Any doubts on this part? Why do we need to develop mechanism for non-elementary reactions? Okay, so there are no questions. Let's move forward. Kinetic models for non-elementary reactions, which is to explain the kinetics of non-elementary reactions, as you said before. So what we do, assume a sequence of elementary reactions which we cannot measure, because intermediate जो रहता है small quantities में रहता है, so we cannot measure or observe the intermediate because they are present in very small quantities. That is hypothesis. So we hypothesize कि ठीक है कुछ बन रहा है intermediate, and then intermediate is giving the product. And then what we are assuming, when you assume this, we assume elementary reactions. जितने steps रहेंगे, they are all elementary, which are used to explain the non-elementary overall reaction. Right? And because it is not measurable, right? So we observe only initial reactants and final products. We can measure initial reactants, उनका concentration measure कर सकते हैं, final products का concentration measure कर सकते हैं, लेकिन intermediate का, because the quantities are very small, it's very difficult to measure accurately. Right? For example, if you look at kinetics, if you see just like we have seen for hydrogen and bromine reacting to HBr, it indicates non-elementary reaction. Right? So we postulate or hypothesize a series of elementary steps or reactions to explain the kinetics. Right? So suppose we have a reaction A2 gives A2 plus B2 reacts to give 2HBr, similar to HBr reaction. A2 plus B2 gives 2AB, similar to HBr reaction. So we can hypothesize as A2 gives 2A star, which is an intermediate. This is an intermediate. Then A star reacts with B2 to give AB plus B star. And then A star reacts with B star to give AB. So we can propose a mechanism, and then what we do is, because these are elementary steps, we can write the rate equation for elementary steps directly and see what is the overall rate equation. And if it matches with the experimental data, then our hypothesis is correct. If not, then we have to propose another hypothesis and again check whether we get the experimental rate equation. So to test the hypothesis or postulation, check whether predicted kinetic rate equation matches with experimental rate equation. So that is the test, right? That's our test. Okay? Any questions? Okay, so types of intermediates, they are based on chemistry. This आपने पढ़ा हुआ है, nothing new. One is free radicals, which is free atoms or larger fragments of stable molecules that contain one or more unpaired electrons. What is unpaired electrons? याद है किसी को केमिस्ट्री में पढ़ा हुआ आप लोगों ने? नहीं याद किसी को? किसी को याद नहीं है केमिस्ट्री? क्या करते केमिस्ट्री पढ़ते कि नहीं पढ़ते?
इजीली रिएक्ट करता है।
क्या?
इजीली रिएक्ट करता है वो।
But what do you mean when you say unpaired electron?
It's a single electron.
Yeah. See, normally in a molecule there are paired electrons, right? They are stable. When you talk about unpaired electrons, they are very unstable. right? They are very unstable and highly reactive. That's why they are very reactive. So you can have CH3 dot, H निकाल दिया हमने, तो H का इलेक्ट्रॉन गया, what you get is CH3 dot with the unpaired electron. C2H5 dot, iodine. Actually, iodine exists as which, in what form?
I2 molecule, sir.
आयोडीन मॉलिक्यूल रहता है, राइट? स्टेबल फॉर्म जो रहता है CH4 C2H6 I2 hydrogen CCl4, right? Or CHCl4, whatever, doesn't matter. CHCl4, CHCl3 बोलेंगे, not CCl4. CHCl3. So if you remove hydrogen from here, hydrogen from here, iodine from here, what you get is unpaired electrons on these free radicals, and they are very reactive and they are very unstable, right? So that is one. So types of intermediates, we are looking at कितने types of intermediates होते हैं. We can propose different intermediates for different reactions depending on what is the rate equation which you want to derive. ठीक है? Any questions on free radicals? Okay. So second is ions or polar substances. Essentially, these are electrically charged atoms, molecules or fragments of molecules, which act as active intermediates. So नाइट्रोजन को एक नाइट्रोजन ऐड कर दिया हमने N3, सोडियम में से एक इलेक्ट्रॉन निकाल दिया हमने, राइट? तो आयन मिला हमारे को. Similarly, OH minus, NH4 plus, iodine minus. So all these things are different ions, right? So these are other intermediates which are possible. ठीक है? And third intermediate is molecules. जो हमने देखा था types of reactions में series reactions, parallel reactions. So if you look at a series reaction, A goes to R goes to S, or A forms R, which forms S. Normally these are treated as multiple reactions. That means we treat this as one reaction, and this is second reaction. But if R is very reactive, its lifetime or half-life is very small, so its concentration in the reaction mixture is too small to measure, right? Just like an intermediate, it forms and immediately it decomposes. So in that case, it can serve as a reactive molecule. That is what this R is going to be. ठीक है? Any questions on types of intermediates?
सर
Yeah.
सर जहाँ इंटरमीडिएट फॉर्म होता है वहाँ रिडिटरमाइन स्टेप होते हैं क्या?
We'll see that. Let's go step by step. First understand the intermediate, then we'll see. वो सब देखेंगे हम. We'll see all those. Rate determining step is what? मैंने बताया था last time. What is rate determining step?
सर वो ओवरऑल रिएक्शन को कंट्रोल करता है.
Right. So which is the rate determining step? How do you decide?
Slowest step.
Slowest, right? Relay race का बताया था मैंने, right? Right. The overall team is as strong as the weakest link. Right. तो जो भी सबसे slow step होगा या सबसे slow reaction रहेगा, that is a controlling reaction. That is rate determining step. Right. So we'll see all those things, but let us first go step by step, understand the intermediate, then we'll see how do we use these intermediates to propose a mechanism, and then we'll see how we test it. There are various steps in the mechanism, and we are going step by step. Just first understand intermediates first. ठीक है, कोई क्वेश्चन है और? So R may not be observed and can be considered as a reactive intermediate. जैसे मैंने बोला R फॉर्म होता है immediately react हो जाता है, right? So it doesn't stay as R for long. Immediately there's a reaction and it goes to S. And the fourth type of intermediate is transition complex. कोलिजन थ्योरी पढ़ा है ना आप लोगों ने? Have you studied collision theory in chemistry or physics? I don't know कहाँ पर, कहीं तो पढ़ा होगा.
Yes, sir.
What is collision theory? नहीं याद किसी को?
सर वो मॉलिक्यूलर वाइब्रेशन पे डिपेंड होता है.
Yeah, but what does it say? Collision theory. Yeah, you are right. Molecule vibration depend करता है. Temperature बढ़ा है तो vibration बढ़ेगा, right? But what does it say? What does collision theory say? किसी को याद नहीं है? अरे इक्वेशन
सर
याद.
दो मॉलिक्यूल का कोलिजन होने के बाद वो रिएक्शन होता है.
Right, exactly. The rate of reaction is always proportional to the collisions between molecules, right? जितना collisions ज़्यादा होगा between molecules उतना ज़्यादा reaction होगा. अगर collision नहीं होगा, collision that means they have to be in proximity, right? They have to be close to each other. If the molecules do not come close to each other, there is no possibility of a reaction. तो जितना collisions होगा, जितना close proximity of molecules रहेगा, उतना ज़्यादा reaction होने का chances है, right? So collisions between molecules result in unstable forms of molecules called transition complexes. Right. So if you look at, if you plot energy versus reaction progress, you'll see that at some point, which is very high energy, we're talking about high energy here, right? यहाँ पर एक what you call transition complex or activated complex बनता है, which is represented as AB star, because if you are looking at A plus B gives AB gives products. Right? If you look at reaction, this one reaction, A plus B gives products. So what will happen is A and B will come together, collision hoga, and they will form a complex AB star, which is activated bolte hain, because it has high energy, and then it will decompose to give products. Okay. So in this case, this is called activated complex or transition complex. So that's the fourth type of intermediate. Any questions on types of intermediates? ये सब पढ़ा हुआ आपका केमिस्ट्री में, बट आई थिंक इट्स लाइक अ रिवीजन. पढ़ा है कि नहीं आप लोगों ने केमिस्ट्री में? यस, नो, डोंट नो?
Yes, sir.
Yes, sir.
पढ़ा है ना? ठीक है. सो लेट्स मूव अप टू नेक्स्ट step in the mechanism development. Once we know the reaction, what we call intermediates, क्या होता है, then we can postulate or hypothesize a reaction scheme, right? So there are two types of hypothesis. Right, which involve these four types of intermediates, right? तो इंटरमीडिएट बना तो उसको हम कैसे रिएक्शन होता है वो प्रपोज कर रहे हैं, हाइपोथेसिस कर रहे हैं, राइट? ये भी पढ़ा हुआ आपका, नथिंग न्यू. नॉन चेन रिएक्शंस एंड चेन रिएक्शंस पढ़ा है कि नहीं आप लोगों ने सब? So intermediate formed in the first reaction disappears in the second reaction to give product. So first reaction भी हमने देखा, हमने A plus B gives AB star जैसे देखा था हमने, right? Just like we had seen this. A plus B gives AB star. ये फर्स्ट स्टेप हो गया. ये सेकंड स्टेप हो गया. यहाँ पर फॉर्म होता है, यहाँ डिकम्पोज जाता है, right? So intermediate formed in the first reaction disappears in the second reaction to give the product. So we can write this as reactants. It could be A plus B, it could be 2A, it could be A plus A, it could be whatever, doesn't matter. ये reactants here will give a intermediate which will represent as star, यहाँ पर करके डालते हैं हम, to say it's an intermediate. यहाँ पर नाम रहेगा कुछ, we are just saying a general reaction लिख रहे हैं, and this intermediate will decompose to give the product. It's non-chain. Why is it a non-chain? Why do you call it a non-chain reaction? Okay, we'll look at chain and then you'll realize what is non-chain. So look at chain reaction. So with reactants, again similar to this one, we'll give intermediate, right? This is chain initiation step बोलते हैं हम उसको. Then in the second step, intermediate will react again reactant to give another intermediate and product, and this is called chain propagation step. And in the third step, intermediate decomposes to give product, which is chain termination step. So if you compare non-chain and chain reaction में क्या फर्क है? What is the difference?
सर टू स्टेप्स में प्रोडक्ट बन रहा है चेन में.
नॉन चेन में ये मिसिंग है, राइट? In non-chain, this step is missing. There is no propagation step. There is initial step and there is a termination step. Whereas in a chain reaction, there is a propagation step. That means जो intermediate बन रहा है, again it reacts with the reactant to give product plus another intermediate. That means it is not consumed. यहाँ पर consume हो रहा है step 3 में, but second step में एक और intermediate generate हो रहा है. So we need very small quantity of what you call intermediate to actually do the reaction. Okay. Any questions? So in the chain reaction, propagation step is an essential feature of chain reaction जो हमने देखा अभी. Intermediate cannot be consumed or not consumed. It acts as a catalyst for conversion of reactant. हमने देखा, it reacts with the reactant to give intermediate again. Each intermediate can catalyze a long chain of reactions. That's why it is called chain reaction. Even thousands before being destroyed. Third step में destroy हो जाता है, right? In third step it is destroyed, but it can keep regenerating intermediate in the second step. ठीक है, समझ में आया difference between chain reaction and non-chain reaction?
Yes sir.
Any questions? कितने लोग को नहीं समझ में आया? Raise your hand.
हेलो सर, कोई एग्जांपल होगा तो प्लीज बताओ ना नॉन चेन रिएक्शन का.
देखेंगे ना, we'll do lot of examples. अभी थ्योरी देख रहे हैं, we'll do lot of derivations करेंगे हम. चेन रिएक्शन का एग्जांपल आपको याद नहीं है? किया है ना आपने केमिस्ट्री में?
क्लोरीनेशन ऑफ मीथेन.
हाँ,
क्लोरीनेशन ऑफ मीथेन.
क्लोरीनेशन ऑफ मीथेन, राइट? क्या होता है उसमें?
सर मिथाइल क्लोराइड पहले फॉर्म होता है, उसके बाद वो CH2Cl2 फॉर्म होता है,
हाँ,
ऐसे आगे बढ़ते जाता है,
राइट.
लास्ट में CCl4.
CCl4, right?
हाँ, यस सर.
So that's a chain reaction. Non-chain reaction, we'll see. There are other there are many non-chain. जैसे हमने देखा था. If you look at elementary reactions are essentially non-chain reactions. यहाँ पर intermediate वाला बाद में देखते हैं, we'll see. But ultimately our objective is कि ये जो steps है, these should be in elementary reactions. When you propose a mechanism of chain reaction, non-chain reaction, all these steps are supposed to be elementary. Why? Why should they be elementary? Can anybody tell me? Why should we write these steps as elementary reactions? Nobody knows why these steps, which are we writing for hypothesis, in the hypothesis, chain reaction, non-chain, why should they be elementary?
rate control step है intermediate का.
Control नहीं, it's not rate control. We are not even talking about rate control. Why should they be elementary? Rate control बाद में आएगा.
Single stoichiometry.
Because we are trying to explain a non-elementary reaction. We are trying to derive a rate equation for non-elementary reaction. So if you have elementary reaction, we can write a rate equation for this step 1 or this step 2 or this step 3 and combine these in a way which will give us a overall rate equation, in which we'll say कि rate controlling step क्या है, which Ritesh is asking many times, right? या जैसे अभी chain reaction में 1, 2 or 3 है, right? There are 3 steps in this. One of these steps is going to be rate controlling. बराबर ना? Right. In one of these three steps is going to be rate controlling. When you look at non-chain reaction, there are 2 steps. One of these is going to be rate controlling. Right. So when you try to derive a rate equation for the overall reaction based on these elementary reactions, we'll combine these in a way so that we can get the experimental rate equation. And to get that, we need elementary reaction, because now we can write the rate of reaction for this elementary reaction is nothing but reactants to the power of whatever stoichiometry रहेगा, right? Similarly, ये जो रहेगा intermediates to power of stoichiometry, right? We can directly write. Similarly, ये step में जो रहेगा reactants to the power of stoichiometric coefficient, right? Propagation में we can write directly जो reactant या intermediate रहेगा उसका stoichiometric coefficient is the order of reaction. So we know we can directly write rate equations for each of these elementary reactions and then combine them in a way which will give us the overall rate equation. And that is why all these steps have to be elementary reactions. If they are non-elementary, then we cannot write the rate equation for each of these steps. Is that understood?
सर तो कैसे डिसाइड होगा कि वो एलिमेंट्री है या नहीं?
We propose elementary reaction steps only. We cannot propose non-elementary because this is a hypothesis. पता है hypothesis क्या होता है?
नहीं सर.
अरे नहीं पता है? अरे इतने साल से आप फिजिक्स केमिस्ट्री पढ़ रहे हैं, hypothesis नहीं पता है? What is hypothesis, देवेंद्र?
सर शायद जो इमेजिनरी होता है.
Right, we propose us से कि ये हम hypothesis कर रहे हैं, that means you are proposing कि ये steps होता है. हमने देखा था proposition, right? Either hypothesis or proposition, right? Either somewhere I had written postulate. That means you propose, ठीक है, ये steps होता है. We are just trying to explain what we observed experimentally by some theory, right? And if the equation derived from theory or proposed theory is the same as the experimental rate equation, then theory is correct. बराबर ना?
Yes sir.
That's how we prove theory, right? We propose a theory and then we observe data and say, अरे हाँ ये मेरा जो data आ रहा है, my theory can explain this data which I have observed experimentally. Any field, you take any field, doesn't matter chemistry है, chemical engineering है, physics है, everywhere it is same. There's a theoretical physics, there's experimental physics, right? Theoretical physics guys will propose कि ये ऐसा ऐसा होता है, black hole theory, ये theory सब they keep proposing theory, and then they see कि data, actual data जो मिलता है from the real world, does it or does the theory predict the same thing as what we observe in the real world? If the theory explains correctly, then it is correct theory. Otherwise, it is wrong, it is rejected. Right. So that same thing we are saying. We just say proposing a few steps. Okay. हाँ ये react intermediate form होता है. We are proposing. Yeah, out of these 4 intermediates, one of the intermediates is formed in this reaction, and it reacts in this form in these steps, 2 steps or 3 steps, chain reaction or non-chain reaction. And then based on those steps, we'll derive a rate equation. And if that rate equation which we derive matches with experimental rate equation, then the theory is correct. If it does not match, then theory is wrong. Then we go back and again propose another theory, another hypothesis, and then again follow the same steps and see whether our rate equation matches with experimental data. समझ में आया?
हाँ सर.
Okay. So we'll continue from here tomorrow. थोड़ा और है इसमें to understand all thing. We'll see a lot of examples of this also, because actually एग्जाम में जो आता है एग्जाम्पल से आता है, theory नहीं पूछता कोई. theory कभी कभी आ जाता है, but mostly they'll give you derived mechanism for this reaction, that reaction, that reaction. So we'll see a lot of examples of mechanism for different reactions. ठीक है.